Let's first do a quick review on tap operations, as this will help us with what we have to do to prepare the breakout cable for use in this scenario. We're looking at a 10 gig tap that is sitting in line between switch 1 and switch 2. Our taps come in a range of light budgets. For the purposes of this example, let's assume that the tap is a 70-30 split. What that means is that a packet that originates on switch 1 bound for switch 2 will be split with 70% of its light going off to switch 2 and 30% of it sent out monitor port A. Likewise, a packet that originates on switch 2 bound for switch 1 will have 70% of its light sent to switch 1 and 30% sent out monitor port B. As such, both monitor ports A and B are transmitting light. Monitor port A for those packets originating from switch 1 bound for switch 2, and monitor port B for those packets originating on switch 2 bound for switch 1. So a standard straight cable is not going to work for us because the transceiver on the other end of a standard straight cable expects to transmit and receive, and what it's going to get here is 2 transmits. As a result, we need to split these two into 2 separate ports on the tool, or in our case on the packet broker. Ixia provides a special cable, makes available a special cable that, if we were to look very closely, has DCE on one side of the cable that plugs into the monitor ports A and B, and those are in turn split to 2 separate ports, 2 separate LC pairs, with the DTE on the correct side for the transceiver to receive it on 2 separate ports. With the breakout cable, logically the cable is supporting 4 separate 10 gig connections. Each one of those is a transmit and receive. So what we'll have to do is tear apart this cable so that we can get to just the receive side of each of these 4 logical ports.